Hello, welcome to another Brookbanks Podcast. I'm Ben Wakeling, your host. I am here today with Toby Crayden, who is Technical Director at Brookbanks, and we're going to be talking about all things earthworks, cut and fill, muck, subsoil, whatever you want to call it. I know from my time in house builders that it can be a real source of contention and cost. And so what we'll do today, we'll chat through with Toby about how to mitigate any cost, what cut and fill is, how material can be used, all those great things. Toby's going to educate all of us on all things muck.
I do hope so. I do
Yeah,
hope
I'm
so.
sure you will. Just to start off with, before we get into the detail, Toby, could you just give us a quick introduction to yourself, your journey
Yeah,
to here?
yeah, sure. So thanks, Ben. Hi all. So as has been said, I'm Toby Crayden, a technical director within Brookbanks, and my background is mostly in the residential market, doing civil engineering. And yeah, delighted to be here to talk to you about cut and fill today.
That's great to have you. Right, let's talk about mud, shall we? Um, or cut and fill is like the technical term is. So let's start big and zoom right out. What is cut and fill? When people talk about it, what are they really talking about?
Cut and fill, it's a bit of a catch-all phrase, really. Cut and fill it means different things to different people, but basically it's all about material management, both on and off site. And different members of the project team will have a different view on what they want to get out of a cut and fill. A client might typically be looking for a balanced cut and fill, as that generally suggests the cheapest earthworks solution, not necessarily the cheapest overall project solution, but traditionally it's been taken that a balanced cut and fill is the way to go. A contractor, on the other hand, might take a cut and fill exercise and be looking at more of the detail of the phasing, the material that's being taken out of the ground, and therefore material handling. How's he going to stockpile it? And even down to what's the weather going to be like when he's actually on site. So how is that material going to behave? It will come out of the ground. It might come out dry. If it then gets wet, particularly if it's a particular clay material, it'll behave completely differently. So he's going to be looking at a cut and fill not just from a volume point of view, but from a more granular, I suppose, to coin a phrase, what's it actually consisted of, and how is he going to be using that on the project. So
Hmm.
a cut and fill exercise is a very important part of site delivery. It's an important part of the design process, but its complexity and importance is really masked by the simplicity of the request. It's quite often something that's tagged onto a scope of works. It is in danger, it's sometimes, of being a tick box exercise, something that's done very much at the last minute. After all of your level design has been done, your drainage design, etc., a cut and fill exercise might be done. It's handed over as part of a project pack, sent out to tender, and effectively the contractor is left with a bit of a fait accompli. It's not really a considered part of the design process. That's
Mm.
that's the danger.
Well, in my experience, as I say, I've had plenty of time in house builders, and I'm not saying this is true for all sites, but it's always been the case at kind of early pre-construction feasibility stage. It's like, oh yeah, the site balances,
Mm.
and the site inevitably never balances, and we're left with great mounds of topsoil and subsoil on site, and looking at really quite expensive bills to take that muck off.
Yes.
So I'm interested in a couple of things that you said there. First of all, you said earthworks is kind of tagged on to the end and often leads to these kinds of things. What do developers and clients often miss when they're thinking or not thinking about earthworks? So just to illustrate that, in my experience, people will look at an overall site and say, oh yeah, the cut and fill balances, but they won't pay attention to the sequencing of the site, the programming of it, what gets dug first, and that's where you end up in problems. And are there other pitfalls that and traps that people fall into?
Yeah, there are. So you are exactly right. I mean, typically those sorts of things wouldn't be at the forefront of people's minds, but it's actually considering the cut and fill holistically with the whole project, and it's really understanding what is the client's cut and fill strategy, because there is generally risk in the ground, and traditionally that risk is handed over to someone like a contractor who's the guy that's standing there with the spade that has to do the work. But what's the client's cut and fill strategy for reuse of any arisings? Do we want those arisings? Can we reuse them on site? And particularly with the advances that have been made in recent years over soil reuse. So with soil mixing, we can be reusing some of those arisings in the trench. We can use them under the roads. We can use them as a general fill material. They can be used in landscaping. Again, traditionally material would just be taken out of the ground, stockpiled. It could then be generally reused around the site, but not with the same sort of degree of flexibility that you've got now. So a client's cut and fill strategy might well be to generate some extra material and actually actively use that on the site. And that way you would actually reduce the amount of imported granular material. So you're not only reusing what you've already got, bit of soil mixing, put it back into the trenches, but you're also saving on those import costs as well. So I think it's treating that cut and fill exercise as an integral part of the design process. And you might be raising levels because you want to avoid, say, a pump station, or you need a connection to a ditch, and therefore those levels might need to go up. But the actual looking at the phasing of a site, you might be able to generate that extra material as some of the risings, and then use that on another part of the site. So it really is such an important part of the whole design process, not
Yeah.
something to be left right at the back end.
Yeah, I mean that you've touched on the second thing that piqued my interest was obviously being a commercially minded person was about the cost and those things that you can do to limit cost. It's not all about just what can you reuse on site and what can you take off, but how can you reuse the material on site.
Yeah.
Things like soil mixing, which sounds sounds quite interesting. It also sounds like it might have an awful lot of regulation around it and
Mm.
rules and so on.
Yeah. Yeah.
Am I right in saying that?
Yeah, absolutely, and it's one of the most heavily regulated parts of the industry, and certainly there are a lot of there's lots of legislation around how that you can extract, handle, dispose of arisings on a site. You've got Environmental Protection Act, you've got the Waste Framework Directive, hazardous waste regulations, control of asbestos regulations. You've got to have the material properly tested. You've got to have your site waste management plans in place. And then you've got the lovely Finance Act, which introduced the landfill tax as well. Even if you've got this excess material and you can't design that out from a level point of view, you've explored your options to reuse it. You've then got to think about, right, if it's got to go off site, how am I going to achieve that? There are commercial sites available which will look at putting sites in contact with each other. So if you have a surplus of a particular material and they know of a site which requires that material, there are ways commercially in which you can have those conversations. Um, but I guess the fallback position, the last stop in the road is, okay, we've got to take this off and it's got to be disposed of, and then you end up having to pay landfill tax, and landfill tax is always going up. You've got about £130 per tonne at the moment in landfill tax. If you go for the inert material, it's now £8 a tonne. That's up from £4 a tonne from last year, so that's doubled. So there's a real drive from both a government and an industry point of view to prevent material just being tipped, disposed of, without all of those thought processes going in first about, do you actually have to generate this material? Is there some way that can be offset? Can you keep it on site? If you can't keep it on site, can you change it into something else? Or is there someone else that can use that material in its current form? So yeah, certainly regulation is looking to sort of drive the right behaviours, but there are all sorts of cost, commercial, program, environmental advantages, in those options as well.
Yeah, and apologies in advance if this is a really daft question. So I understand, obviously, subsoil, for example, it gets tested, it's clean, it goes off site, and and you mentioned there about there's software and systems and commercial things available where you can take it to another site that needs subsoil, and that's when I was a QS, that was our first port of call, is ringing up QSs and other developers and saying, "Oh, do you need 30,000 cube of subsoil by any chance?" And here's the daft question: if it doesn't go off to another site, where does it go? I mean, is it literally it goes to a landfill, it just gets dumped in what, big field?
Yeah, you are literally looking at sites where it might be an old quarry, it might be an old borrow pit, it might be used for if it's an inert material, sort of for capping on top of landfill sites. It will literally just be used wherever it can be dumped, for want of a better phrase, and lost in the landscape. And that's okay. You could argue that is fulfilling some sort of purpose, but it's not fulfilling its primary purpose. It's not really being reused in construction. You've got transport costs. You've got the carbon impact of transporting that material. The way that that's then going to be affecting the local residents as well. The number of lorries that are going to have to come to and from the site. It's just a very negative way of dealing with a surplus of material, which, in reality, there are so many clever things that you can be doing with soil nowadays that just shouldn't be necessary. You can treat the material in the ground. You can do lime stabilization, for example, is a very tried and tested method of improving the conditions. You can extract it, soil mix it, and replace it, recompact it, and replace it. And again, there are some really clever options in the market that can mix the soil in a particular way to get particular properties that you need out of it, depending on where it's going. Again, if you're reusing in back gardens, topsoil mixing, again, it's a very well established, tried and tested method of taking a material which is suboptimal for that particular location, but with the proper right of mixing and propagation, you can actually then successfully relay it. I know, I'm the number of times that I've seen in my past years of being on site, and you'll see just general material taken out the ground, stuffed in the corner of the site, and then right in the last few months of the site, it's taken, laid in back gardens, some turf goes down over the top. First time it rains, you're left with a paddling pool in back gardens because it's been overworked, it's not been placed correctly, it's just not the right material. Whereas now there's a lot more that can be done in testing the material, avoiding that double, triple handling, and making sure that that material is fit for purpose. And I know, building control, for example, are very hot on that type of stuff, so that you don't leave a resident with a garden that can't be used, or worse, you're not reusing that material under roads, in trenches, and again, it's not suitable without the proper testing, proper certificates, and the proper manual handling.
And how long does it take to get these tests back? Because most developers might be listening to this and thinking, well, that's all very well and good, but I've got to build 200 units this year. I don't have the time to sit and mix it on site and get all the testing. I've
Yeah.
just got to get it off site. Um, I mean, that sounds like a bit of a reactive way of thinking, and I suppose what you're going to tell me is it goes back to what we were saying at the start. You've just got to give some actual thought to cut and fill and
Yeah.
earthworks and soil management and where you use it and so on, I
Y-
presume.
it is. It's absolutely, and it's from day one. And I know a lot of this applies to the whole design process, but that's exactly where the cut and fill exercise sits in that whole design process. So, you know, as soon as you know you're going to be working on a project, get to site, have a look at it. What does it look like? What does the site feel like? Can you get a sense for how the site is currently draining? Is it absorbing the water? Is it shedding it off? Are there a load of ditches? Kick some dirt over. Is it bone dry? What are the properties that you're actually working with? And that's going to start giving you a really good feel for what your cut and fill should be. Is this a material that I want to be working with? Can I reuse it? How can I reuse it? Is it going to be suitable for some of those processes that we've touched on? And that's before you start putting pen to paper, looking at levels and drainage. You should be thinking about um, how is that landscape going to be ultimately left? Am I going to have a surplus? Do I need to bring material in? How is the site going to be? How is the site going to be phased? And then the next stage is, okay, I've got a physical sense for how that site feels now, but we haven't got X-ray vision. So how good is the site investigation? Is it giving me the right information across that site? Does it tell me the soil properties across the whole of the site? Is that consistent? Is it consistent at depth? How much excavation am I going to be doing? And really, you need to be ensuring that that site investigation gives you that whole picture,
Mm.
so that when you're looking at your levels and when you're looking at your drainage and you're thinking, right, I think I'm going to have to raise a bit of the site here, I'm going to have to lower it here, in your engineering mind, you're also thinking about, right, that is going to be generating a certain amount of cut. I've got in my mind's eye, I can sense what that material could be reused for, where it could be reused on the site, or does it need to be treated? Am I going to have to give some early warning to the client that actually I think we might have some surplus here, and you need to start thinking about what other sites have you got that might need this material? What impact is that going to have on the levels and the cut and fill for that particular site, or as you quite rightly say, other sites that might be around that might be able to reuse it. So it is a very much a day one. It doesn't take some thinking about, but it is very much a day one process. Absolutely, absolutely. And when it comes to the testing, again you're quite right. It needs to be tested, needs to be taken away to a lab, etc. So again, it's putting that forethought into it to make sure that you're not caught on the hop. You haven't got a load of material that's sat there and it's effectively gone off. Yeah, you don't want to be moving it around the site several times, and you end up with that double and triple handling, which is just going to ruin the base properties of a particular material. It all needs to be planned out, and that's where the contractor skill set comes in. That if they can see that that cut and fill exercise has been done with a bit of thought and a bit of care, and that's been documented as well, which is another key point. So many times you just see cut and fill drawing handed over, and it's very colourful, and it'll have a little table in the corner that says this generates X amount of cut. But where's the story behind that? Where's the borehole section? Where's that piece of text that actually says, as an engineer, I've thought about this, and I think that you might be able to reuse this, in these particular areas. How accurate is that cut and fill? So, again, we've all got an idea of what sort of arisings a typical house footprint might generate, for example, but test it. Look at the client's house footprint. Look at your typical foundation details. Are those assumptions still correct? Because if you're then multiplying that over a 200, 500,000 unit site, you're going to be introducing those creeping errors into a cut and fill, and what the contractor ends up with at the end of the day might be completely different from what you thought you were going to be delivering for him as part of your level exercise. So I think it's also very important to just make sure that if you're going to the time and trouble of making sure you've been to site and everything is as accurate as possible, and you've jumped through all those hoops, don't then ruin it by just making some bland assumptions on, I think I'm going to generate 40 cube for foundations, 5 cube for some drainage, and 3 cube for some utilities. Sit down and do a little exercise and just make sure that those are in the right sort of ballpark, and then you can make sure that that's factored into your cut and fill assessment, and also some things like, typically you'd allow for some topsoil strip. That's fine. You can make some assumptions based on the site investigation, but then once the site work has started and that strip has happened, just go back and check or ask the question or make sure that it's clear in the assumptions on that cut and fill exercise. These are the assumptions we've made with the arisings. We've assumed you're going to take 400 mil off. If you take 600 mil because you've been a bit overzealous, or you've actually found that the topsoil is a bit thicker than might have originally been thought, that needs to go back into the process. What impact is that having? So it's very much an iterative process. And again, the danger is traditionally you've seen, yeah, just make sure you've done a cut and fill, one iteration, tick, it's done, it's put in the pack, it's completely forgotten about, and then you end up being super reactive when the ground worker suddenly starts saying, guys, we've got some material being generated here, and we're not quite sure where to put it, so we keep moving it around, and we're not quite sure how we're going to deal with it, and then you end up having to replan the phases as they pan out. Whereas a lot of that could potentially have been dealt with quite early on, but it takes thought and it takes effort, and all that needs to be built into the process.
Double handling was always a real bugbear of mine when I was at a QS because I just felt it, completely unnecessary. You don't have to do all that if you think about it properly. And I hadn't actually given any thought to how it could be affecting the actual properties of the material itself. I was just worried about the pounds and the pence. And there was always that myth, wasn't there, that topsoil could be sold. No one's buying topsoil. That's nonsense. What ended up happening inevitably was it would just got spread over the POS, where you get those nice little mounds, wouldn't you? You'd lose a bit in a mound, lose a bit in a mound there, ended up looking like Teletubby land across your public open space.
Yeah, try and make it look like it's a designed piece of the landscape, and make sure nothing's left at the end of the day. But
Exactly.
yeah,
So have you got, all this sounds great in theory. Have you got any examples of where, a good earthworks and good cut and fill and good soil management has actually paid off?
one springs to mind that we got involved with, it's it's a pretty simple example, but it did demonstrate how the cut and fill exercise did change the strategy that we had on site. So it was working on a lorry park, so the site was very large. The levels were pretty fixed, both at the boundaries and across the site. We had no opportunity to introduce retaining walls or anything like that to sort of step and stagger the site. We pretty much had a flat site from edge to edge. It was designed, being a lorry park, we had a fairly thick concrete slab for the loadings, as you would expect, and that was generating X amount of surplus material. And it was a few years back when the client was basically not particularly interested in what the cut and fill exercise might tell him. It was more so that it could just be priced by a contractor. Just make sure it's part of the pack. It will go off with all the other drawings. We'll get some tenders back. We'll choose the one we like the most, and off you go. Um, we did the level exercise. We designed the slab. We came up with the cut and fill. But it was really a moment when we thought, oh, hang on a minute. This is we can do better here. This is telling us that we've generated X cubic meters, and there's going to be nothing wrong. We're not going to be outside of our scope. There's going to be nothing wrong with just handing that pack over, helping the client deliver the site, and it will all go great, and we'll move on to the next one. But we actually thought that we should be using this information in a much cleverer way. There should be something we can do with this. So we started to look more at the site investigation, look at what the sort of soil properties were. It was a clay site, and we thought this could lend itself to some soil mixing. We could do some lime stabilisation here, and if we do that lime stabilisation, we were able to do some calculations to show what impact that would have on the slab, on the concrete slab. It would actually start to thin up the slab because we would have a much better base to put it on. So there was some time, effort, and cost to go in at the front end with the lime stabilisation. But overall, there was some significant project savings to be had because the slab got thinner, the amount of dig was much reduced, and it meant the overall program could be reduced. So the client could actually get his scheme a lot quicker. So we worked with a specialist lime stabilisation company. We worked with the client's preferred contractor, and we came up with a scheme which ended up using the lime stabilisation. The concrete slab ended up being much thinner, and as I say, it got delivered much quicker, and the client was much happier, as you might expect, because of those overall savings as a result. But there'd have been nothing outside of our scope in delivering the first option, just to go with the simple cut and fill exercise, get it priced, off you go. But we decided that there was, as I say, there was a much better way of potentially doing this. we could have done the calculations and found that actually it was pretty neutral, or maybe there wouldn't have been that much saving. But we actually got such a good result out of the lime stabilisation. The contractor was very happy as well, because although you might argue, he lost a bit of revenue because there wasn't quite as much to take away, he had a much better surface to run on as well. So we did the lime stabilisation. It was given a CBR results of in excess of 50%. It meant that he could put all of his site cabins straight on the ground. All of his deliveries could just be put straight on the ground. He had a great surface to work off, a little bit of trimming, and then the concrete could go down, and Bob's your uncle. There you go. You had a very nice, stable, and I think much better um, lorry park at the end of the day, because you knew that you were putting your concrete slab on a really good subsurface. So it was just an example of these things don't need to be complicated. We didn't have any long lead-in times. We were able to shorten the program, reduce the overall costs, and it was a win-win all round for everyone. The client was very happy that we'd been very proactive. He'd saved some money, and the contractor did a really good job. And we actually went on to do further schemes with the same client and the same contractor team. It went so well on site, the client decided to roll out exactly the same team on similar projects after that. So yeah, just trying to
Brilliant.
think of a reasonably sort of simple example to
That's a
show
good
that it
example.
doesn't have to be an overly complicated process.
Yeah.
It just needs everyone bought into that process, and you just need to be giving that cut and fill exercise the same standing as any other report exercise that you do as part of that design process.
Well, this is it. It's there's a few things there, isn't it? It's about sometimes you have to spend a bit more money up front to save money in the overall. I think just in general for the layman like me, soil and chemicals and properties of soil is such a dark art that it's this is where getting proper engineers like you involved, could pay dividends. Brilliant. Okay, well, as we come to the close of the podcast, if there's any developers or landowners listening who've got a nice piece of land that they want to build on, what would be your key pieces of advice to them in terms of earthworks and cut and fill?
I think it's understand your site. It's make sure that you understand what your site consists of and what the possibilities are with that site. So a good site investigation is a must. You've got to know what you're working with. We can do a certain amount of desktop research to see if it looks like the site has been previously developed. Has there been any changes in the landform that might suggest that there's been material moved on or off site? But a good SI, get your engineers to site, get someone to do that site walkover. You can learn so much from looking at a site, and I know, and it's going to sound strange, but just getting a feel for it. As engineers, you tend to develop a really good sense of feel for a site. Has it been mucked around with? What does it, how is it dealing with the rainfall? How is it dealing with surface water running off from adjacent sites? Is it a dry site? Is it a boggy site? You can learn so much just by standing there and digging your heel in and just kicking a bit of turf over and just seeing what that feels like. I think from a
Okay.
client point of view as well, just making sure you've got that right engineering support around you as well. So, you get a good feel from your engineers that they are working hard for you and that they are looking at things like this, that they are looking at the bigger picture. They're looking at the site from a cut and fill point of view from day one, that it is not a tick box exercise, that you are really looking to practically assess the site from a level, a drainage, a materials point of view. And also, I suppose, a shout out to clients is please pay for a decent cut and fill exercise. You get what you pay for, and if your cut and fill exercise is a tick box exercise, that's what you're going to get back, and you're going to be missing out on all of these opportunities to make it an integral part of the whole design process. And I know, projects will have different pots of money at different stages, and traditionally there's perhaps not there's not a lot of money at the front end of a site, particularly if you're looking at that land acquisition and you're trying to get a sense for how it might be developed and what the return might be. But it is money well spent. And it will pay you back in dividends, as that site is developed and then finished, and there's a big ribbon cutting ceremony and everyone slaps themselves on the back about how great it went. Well, it went great because you had the right team and the right information from day one.
Yeah.
They're the most successful sites when
And
you've got it set it up for success from day one.
nice. I like that tagline. And you're not standing at the on the last few months of the site, looking at a big old pile of dirt, thinking, "Oh,
Yeah,
that's going to cost an awful lot to get off."
absolutely.
I've got a great image of you now, Toby, in the middle of a field with your high vis and your boots on, and you're kicking the mud, but also you're picking up a bit and you're rubbing it in your fingers, and
Yeah.
you're touching it on your tongue, and you're going, "Well, that's got contamination in it." That. It's like some kind of
I'm like a horse whisperer. Yeah, yeah. Indeed.
excellent. Well, thank you very much for coming on. Thank you for your
No problem.
time. If anybody is listening and wants to learn more about cut and fill, about earthworks, about whatever it might be, what's the best way to get in touch with you?
Yeah, please do drop me a line. My email address is toby.crayden@brookbanks.com, and I'm sure we can flash that up on the screen so that people have got a copy of that. But yeah, reach out or go onto our website, and all the contact details will be on there. We'll be happy to help.
That's it. You took the words out of my mouth. Brookbanks.com is the website. You can find out everything about what we do on there. You can get in touch with either myself or Toby. But that's great. Thank you very much, Toby. It remains for me to say we'll see you next time on another Brookbanks podcast.
Look forward to it. Thank you very much. Cheers.